Hey, it's Mr. Lineski, and we are looking at Unit 6, Section 1. Unit 6 is all about triangles and different parts of triangles. It's kind of vocab heavy, so if you take a look at all of these words here, these are all words that you should know the meaning of, hopefully by the end of the video here today. So let's get started. Our first word is a midsegment of a triangle. A midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. Every single triangle has three midsegments. So if you think about that, a triangle has three sides. Each of those sides, I could say, has a midpoint. I can cut it in half. And if I were to connect all of those points, what I essentially do is I create another smaller triangle. And each of these three lines here is referred to as a midsegment. So you sort of get a little Triforce looking thing from our Zelda games. I'm not going to look at all three midsegments, I'm just going to look at one. So what exactly does a midsegment do for us? Well, a midsegment is any, in a triangle we can say that the midsegment is parallel to the side that is opposite of it. And we can also say that the midsegment is half as long as that side. So here, if I said that this had a measurement of x, then I could say that DE had a measurement of x divided by 2. In other words, if this were 10, this would equal 5. So that's what a midsegment does. So a median is a type of line in a triangle that cuts a side of the triangle in half. What we kind of want to think of is that it connects an angle to a midpoint. So if I had a triangle ABC, and I found the midpoint of AC and said that the midpoint was point D, and then I connected the opposite angle to that midpoint, and I create what's known as a median. So a median is kind of like a segment bisector. It's cutting a segment in half through one of the vertices and its midpoint. An altitude. An altitude is the perpendicular height of a triangle. Perpendicular being the key word there. So if I had a triangle, once again, I'll just call it ABC. If I wanted to draw the height from, let's say, angle A, it could look something like this. So it has to be perpendicular, it has to meet at a 90-degree angle. Every triangle, so kind of going back to medians as well, every triangle has three medians. Every triangle also has three altitudes. So I drew an altitude from angle A. I could also draw an altitude from angle B, and I could also draw one from angle C. But they all have to sort of meet at that 90 degrees. Something strange happens that if the triangle is obtuse, if you have an obtuse triangle, meaning that one of the angles is greater than 90, what happens is that your altitude ends up being outside. So let's say I wanted to draw an altitude from this angle here. Well, there's no way that I can draw a line coming into here to make it 90 degrees. So what I have to do is sort of extend out the triangle, and then you sort of drop this down and create your altitude there. So remember, every triangle has three altitudes, every triangle has three medians. A perpendicular bisector is if you sort of mush those two ideas together. If you combine a median with an altitude, so median cuts a line in half, altitude meets the line at a perpendicular 90-degree angle. So now if I have a line that does both of those things, if it meets at a 90-degree angle and it cuts it in half, that is called a perpendicular bisector. So these are sort of the markings that you're looking for. You're looking that it's perpendicular, and you're also looking that it's bisecting. And then finally, angle bisector. In an angle bisector, it does exactly what it sounds like it does. It bisects an angle. So if this line here was an angle bisector, we would say that it's cutting the angle in half. So A, B, C, D. And I could say that AC is the bisector or angle bisector. And then we could claim that angle BAC is congruent to angle CAD. So again, what does it do? It cuts an angle in half. Something else that you want to look out for in an angle bisector is if you just have an angle, not necessarily a triangle. And then if I draw an angle bisector, or I draw a line, and I want to know, is that line an angle bisector? What you're then looking for are marks that look like this, and then they indicate somewhere that they meet at a 90-degree angle. So if these conditions are met, where it's congruent and 90 degrees, you could also say that this line's an angle bisector. And the reason that that happens is if I mark this as my shared side, you end up with a hypotenuse leg situation, and therefore the triangles are congruent. So some of that stuff kind of comes and loops back around. Talking a little bit more about perpendicular bisectors, there's something called the perpendicular bisector theorem, which basically says that if a point is on a perpendicular bisector of a segment, then it is equidistant, just meaning equal distance, from the endpoints of the segment. In other words, if I have CP, and I tell you that it is the perpendicular bisector of segment AB, so if I tell you CP is perpendicular bisector of AB, then I can claim that CA is congruent to CB. So I would be able to mark this. Again, the reason that we can sort of do that is we have a side angle side situation going on here. So using CPCTC, we can mark these sides congruent. The converse to the perpendicular bisector theorem states that if a point is equidistant from the endpoints, then it is on the perpendicular bisector. So if I have this, I can claim that this line's a perpendicular bisector. So in other words, if I tell you that XA is congruent to XB, then I can say that XY is the perpendicular bisector of AB. And then I can make claims such as AY is congruent to YB. So let's take a look at a couple of example problems here, just see how we sort of utilize this stuff. So we're solve for the missing variables provided that the given line is a midsegment. So you need to know the vocab, midsegment. Midsegment tells us that these points right here are midpoints, which means this is congruent to this. It means this is congruent to this. And it means that this side right here is equal to half of this. So if I divide this by 2, that will give me what x is. So let's start there. 8 divided by 2 tells me that x is 4. Y, if this is 6, that means this is 6. And for z, if this piece is 5, then this piece is 5. Over in problem number 2, it says use triangle ABC where DE are both midpoints. Therefore, this is a midsegment. Given that DE is 5x minus 7, and given that BC is 3x. So now here's an example where we don't have a number, but we can still keep up sort of our idea that the big side, 3x divided by 2, will equal what the midsegment is. So now if I'm solving for x in this problem, I want to start by getting rid of dividing by 2. So I'm going to multiply both sides by 2. Make sure you remember, distribute the 2 to both sides. So that gives us 3x is equal to 10x minus 14. If I subtract 10x from both sides, that gives me negative 7x is equal to negative 14. Divide both sides by negative 7, and I get that x is 2. The problem asks, what is BC? So if I substitute a 2 in for x, 3 times 2 would be 6. So using our logic, if I substitute 2 in for here, this should be 3. So 5 times 2 is 10. 10 minus 7 is in fact 3. So our logic holds up here. Taking a look at this problem, it says solve for x based on the markings. Which type of line is UW? So looking at UW, what kind of markings do we have here? We have congruency, and we have a box there indicating 90 degrees perpendicular. So this thing would be a perpendicular bisector. And then what can I claim now to solve for x? Well, if this is a perpendicular bisector, I know that these two sides have to be equal. So now I can set those equal to each other. I know they're the same. And then solve for x. So I get 4x equals 26. And when I divide both sides by 4, yes, you get a decimal. That's okay. You get 6.5. The next one is just sort of some vocabulary. It says DC is what type of line. So when I look at DC, you want to look at the markings. Markings on DC, we have a 90-degree angle, and that's all we have. So when it's just a 90-degree angle, we can call that an altitude. FA, when I look at FA, what do I have here? I just have that these sides are marked congruent, so I can call that a median. And then finally, BE, when I look at that, I notice that the angles here are marked congruent, so that would be my angle bisector. All right, the other two problems that are on the paper, I would like you to try those on your own. Thank you for watching.